So I'm just going to mess around with a few things, just cheap thrills. So this is the wallpaper, and these have all the tasks. And here's the core swap count. So I'm going to, while true, yield. So right now I have core 0 doing 4.5 million swaps a second. That's not. I have to explain what a swap is. It's a context save and a context restore. So if you go to the scheduler, a context save is it redirects. It's not using the normal stack. It's just using that as a pre-decrement and store. Anyway, it stores the registers in the task record. The task record has a space for all the registers somewhere in here. Where'd it go? Where did all the registers? There they are. There's all the registers. So the task record is pointed to by FS is the task record, and if you look on your window up here where it says 7F9, that's the task record address. So FS is the task record. So if I say I just changed this trace. Okay, so whenever you see FS, it's the FS segment register. Basically, it's used like a general purpose register, but it's a segment register. It's really hard to use, and the only thing it's good for is it's an extra register that makes it convenient. Anyway, so I'm going to talk about, let's see, so we got 4.5 million swaps a second. Let's put it on multi-core. So let's just show, I'm going to make this not recoverable. Oh, what the heck? No, not. My job. And these typically have a, so I'm going to make a, yield. This saves the context and the scheduler loads the next one. So I64I 4I equal, I guess we do 0I less than M multiprocessor count. That's 8. If you look in the top, it's got 8 CPU loads. And we're not going to spawn a task. Oh, we're going to clobber the, why don't we spawn? Let's spawn. That's better. It would work either way. Hopefully. It doesn't matter. That's the name that appears on the wallpaper in other places. And now we want the processor. So in TempleOS, you put the task right on the core, and the scheduler does not move it between cores. So all the tasks, all the applications run on core 0, and if they need extra processing power, they fire up some slaves on the other cores. So let's watch the fireworks when we run it. Here we go. Pow. Okay. Shucks. Okay, so we got a bunch of tasks. Oh no. Oh, don't do that to me. Okay. So I didn't think we could get 4.5 million on all cores. They have to use the same memory buses for, well, they have cache. What is it doing right now? It's loading in and saving those registers into the task record. So anyway, that's quite a lot of swaps per second. I don't have I don't mess with memory maps. I don't mess with page tables. So mine is really fast. All I have to do is store about, well, you saw, let's just say there's about 40 instructions, and if it's 3 gigahertz, this is what you got. I have a couple locks. Locks are slow. Anyway, so it's really hard to get out of what we just did. I could have put a flag to self-destruct. I just rebooted. Okay, so by the way, to reboot, RAM reboot, and then you tell kernel bin C, and this bypasses the BIOS diagnostics. What this does is it loads the I call this a soft boot. Basically, we have an operating system that can get fragmented, and we like the ability to do a reboot to reset everything. It's not what you typically think of a reboot. I guess it is. Anyway, this one bypasses the hardware reset, and what it does is it puts the kernel in place and resets and starts executing so that it's reset. Anyway, pow. So there is a debugger. You can hit Control-Alt-D if you feel like it, or you can say debug. Let's go ahead and somebody wants to know how to use breakpoints. Am I right? A lot of you have a hard-on for breakpoints. So, if you really want to use them, they are available. God help you. Okay, so how do we use them? Here is the problem. We have a task that is in the editor. You have to keep track of where tasks are created and destroyed. We're in the editor. As a matter of fact, do you see this this edit and terminal along the side of the window? That means the task started as a terminal and then it entered the editor. Now we exit. So as a matter of fact, now it's the terminal. And what happened when behind the scenes, it did an edit. And then if we hit F1, it's deeper. There's another edit. And then if you go back, okay. So to execute this program, we include okay, so it printed 1 million. Now it's so the question is, what is the situation of tasks? So this is all the tasks. Mostly it's just the executive Seth task on each core, and then there's about 4 on core 0. Core 0 is the only core that can have windows. Task rep. So here's the situation. We have a executive Seth task. Seth is the son of Adam. And then on core 0 we have these 2 windows. There's one window per task maximum. There's 1 heap per task. No, that's not true. There's data in a code heap. Anyway, so only core 0 can have applications. They can create slave tasks on the other cores. Anyway, so on core 0 we have the window manager, and 30 times a second it redraws everything on the screen. We're only using a few percent CPU. There's the autocomplete, which is it's not killed, but it's the window's turned off. There's the autocomplete, or I could have turned it off before I did the command. I don't know. And then there's 2 terminals. There's this terminal and this terminal. Those are user terminals. Oh, I forgot. And then there's the Adam task. Adam is an executive on core 0. I call it Seth on the other ones, but it's, oh well. Adam is the father of all tasks. That's why these are indented to show they're children of Adam. Anyway, so in order to debug, you have to understand how tasks work. And each task has a task record off the FS segment register. And so if I include this program, it's going to store the code in memory, and then it's going to execute it, and it's the same task. Now, if I enter the debugger, the question is, what registers are you using when you are in the debugger? That's a good question, isn't it? So if I say debug, I wanted the same command line, but it's just not Windows. It's not windowed. So everything's the same. It has a compiler. When you make a debugger, you want to scale back on you don't want interference from interrupts, so you don't want it interrupt driven. That's if it's a low level debugger. You guys are probably used to we're at a lower level on the system than you're used to. We don't have such glamorous things as what you're used to. Anyway, so at this point, this is the same task. I think we can get out. Gee, there's a help. I really don't use this. I don't recommend using this, but some people are stubborn and they want to do it the way they're used to. Anyway, so here's the problem. The first problem is, what registers, where are the registers? When we take a task and enter the debugger, I can say fs RIP, and this is the RIP that was last stored the last time we swapped out. Now, if we happen to do a yield, then it overwrites all the registers. If you happen to call a command that yields the CPU and lets a swap take place, then all your debugging just got hosed. So now there is little aliases. I think it's underscore RIP. I made underscore RAX. All these are is defines for, that's all they are, FSRAX. So you can edit, there's a handy thing, edit, there's a light editor, add light. You can edit a source address. You'll see. Edit RIP. This jumps to the source code, and we are in debug. Okay, I didn't know where we were. So when we entered debug, that was the that's what got stored into the task record. Remember, FS is the current task record. So the main difficulty with the debugger is keeping track of the set of registers. If you dump FS, if you dump enough, you'll see the registers. Class rep FS. So the registers will appear somewhere. There they are. There's the registers. So they're stored on the record. So these numbers are 16 digits. Most of them are 8 digits, but in theory you have to enter 16-digit numbers. That is no fun. And the worst part is you don't have screen real estate in order to do anything. I made a little IDE that had a watch window, and it had it pulled up source code alongside the what I tried to do is have two windows, one for the program being executed, another for the source code, and it was a nightmare. So I have on my website the remains of a IDE. It would need some work. Anyway, integrated development environment. So apparently we have some recursive. It's printing out the neighbors of the task, the children or something. Class rep prints so many layers deep. So the task has a successor, and when we did the class rep, we are now seeing what the successor was. I think we're going to abort this. How do I do that? I don't know. Okay, there's no way, there's no interrupts. I just have to reset it. Okay, so if you want to set breakpoints, I just want to show that it is possible. So first of all, we don't want to execute the program yet. Okay, let's include this. Let's debug. Let's unassemble function main. Let's set a breakpoint for address main plus 0x. Let's do the print, right on the print, 1C. Okay, you can see how this works. Now we say, now you have to keep track of, you have to keep in your head what registers are what. There's a set of registers that are doing the command line, and then there's a set of registers that are in the current task record. We haven't, every time we swap in and out, they get updated when we change tasks. Anyway, so if I say main, so I don't know, I guess we're at the right. There's the unassembled instruction. Now you can single step, but you have to step over the breakpoint first. I think, yeah, so you have to disable the breakpoint. I could do this again. Go, let's say go. I don't know if that's going to skip. I think we have to single step over the breakpoint. Otherwise it'll go. Okay. It gives us warning. Single step. So you have to single step over the breakpoint. And then you say go. And then we get back to the breakpoint. It's in a loop. So it's kind of ghetto. Let's look at the warning again. So we can single step all day. Single step. Let's see. Let's unassemble. Unassemble. Watch what I do. Unassemble RI underscore RIP. So we're getting some $ commands. Push BP. Okay, so we stepped into the print. That's where we are. And we can single step. It should let us single step. We're single stepping our way through the function. Now, let's let it rip, go. And we're back at the breakpoint. We can get rid of the breakpoint. Let's just hit go to. Hit G2. This removes the breakpoints and goes. Oh no, you know what? Oh, it's not going to. Okay, so the normal window manager only updates 30 times a second. This is updating every single line. So as a matter of fact, we cheat normally because we don't show all the intermediate line numbers. Okay, I don't feel like this is taking too long. So I just proved that you can do breakpoints if you really want to. I'm really lost when it comes to when we're in this situation. I don't know all the places where there are yields at the so when you're doing directory, I think there's a yield if you do a directory. I'm guessing. So I don't know for a fact. If there were if you happen to do a directory in the middle of debugging, it would overwrite your task record registers. And now what? Anyway, so if you have suggestions for how we can improve debugging, first of all, we don't have real estate. We don't have screen real estate. It's always going to suck. So the best thing is I have some really nice. If you say raw print, then you say, let's say 2000 hello. That's not what I wanted to do. I forgot how it works. Raw print milliseconds format. No, that's correct. Something's broken. Is it? Oh, there it is. It's up at the. It was up at the tip top of the screen. This is for a black and white. To use the slang. Okay, so it's printing hello across the top of the screen. You'll note it. Watch the top of the screen. Okay, so there is a. That is outside the normal window framework. And so what you can do, normally tasks are, I guess you'd call them headless or headerless or something. A lot of tasks don't have a window. And if you want to output from a task that doesn't have a window, you can use raw print. You give it milliseconds to stay there. This just locks the system and displays a message. So when you're doing multitasking, here's another reason debugging is doesn't work real well. with TempleOS. When we do our games, let's go to our games directory. All the games work with a draw it callback. So what that means is there's one task that's doing this. It's getting keys and responding to keys, and there's another task which is drawing the screen. The window manager calls this code. Now, one of the first problems is when you're debugging, you need to set your hash table for symbols if you want symbolic debugging. Let me give you an example. Let's say we want to debug. Let's do that. Okay. Let's say we want to debug for some perverse reason we want a single step this draw it. Okay. So here's what we do. Let's do that. It's a draw it. I'm gonna comment this out. Hit F5. Okay, so this is the task. Right now the code is in memory, and we're waiting to do Wenceslas. Now the window manager, we want to set a breakpoint in the window manager task. As a matter of fact, breakpoints are owned by the task. They're removed and inserted. So we cannot set a breakpoint for the window manager. What if we just... Okay, TempleOS, you can do anything. So you know what we're going to do? The opcode for a breakpoint is CC. So what we are going to do is we're going to say unassemble function. Oh, I just ruined the surprise. Okay, well no, I didn't ruin it. So it's a long function and it prints sprites, and damn, that's a huge function. I think it's the data. Okay, the data for the meshes is actually after the function. Let's just unassemble. Okay, so here we are. Let's go to the pen width. Okay, so we are going to pen width equals 1. Let's put a breakpoint there. So here's what we do. So the symbol table is, each task has a symbol table, and all tasks inherit symbols of parents. You know what we're going to do? Let's say, okay, we'll be a wimp. U8 star B equals address draw it plus 0x. We want the pen width 4D. Star B equals 0x CC. Okay. We just put a breakpoint instruction by hand. Now when we run this, it's going to crash when the window manager calls it. Now let's plan ahead, and what we're going to do, we're going to tell Adam to compile some code. Adam is the father of all tasks. we inherit everything Adam has. So I'm going to say, let's just call it an I64. I64 saved. Oh, this is tricky. Okay, let's just call it saved. Equals fs hash table. Okay, this is the symbol table for the current task. This has the name of draw it. If we want to see what's in the symbol table for the current task, we say who. Oh God, I hope this is correct. I better do little r. Okay, so those are all the symbols when we compiled that code. There's draw it. Anyway, so we want to display the hash table. Let's go ahead and store that into, we're going to create a variable inside the Adam task. I'm just planning ahead. So we stored the hash table address. And now the problem is the window manager, when it hits that breakpoint, if we unassemble, it's not going to have the draw it in its symbol table, and the unassemble will not show the symbolic name. It doesn't scan all tasks. I thought about that. Anyway, this is a single address map. However, you only have symbols for your current task and parents. I could scan all tasks for symbolic debugging. Anyway, so we go debug. No. We say Wenceslas, and then it's going to hit that breakpoint. I was getting worried. Okay, now it says interrupt 3, and we don't have symbolic debugging. Now what we do is we say fs hash table. This totally hoses it. Well, no, I don't know about totally. Saved. And now if we say, oh, look at that. You see now it says draw it 4D. So now it knows what unassemble function. Oh, we remember it's a really long function. Draw it. Long story short, now we have symbolic debugging. The reason we had to do that is because it's a different task. So I don't know what to tell you. If you want to use breakpoints and you want to use the debugger, you're nuts. But what I recommend, to be quite honest, is I do a lot of I make a lot of use of see these progress 1, 2, 3, 4. What I do when I'm in the middle of something, I'll just say progress 1 equals king milliseconds, and then I hit F5, and then what'll happen is it'll write to the progress variable, and then I can see it. Or I'll use it if progress 1. It's just a global variable. If progress 1 is greater than 100, progress 1 plus beep. Sometimes I use beep. There's a beep that blocks. This one does interrupts. But if you say 500 comma true, then that doesn't use interrupts. That turns off interrupts. Anyway, and you might put a, you can put a raw print. I don't use this, it's a little too much typing. But this is a printf, so you can say %x. You can say %p. And if that hash table off your task is, that's what it uses, the hash table off your task. And if you want to see what's in your hash table, I never use this because I always know. This tells who's in your hash table. And I'm going to see if when a surgeon checks for sponges, I do a merge check all the time. I have my D drive is an exact copy of my C drive, and throughout the day I'll update it, and then I like to do a merge check. You can check my files on the distribution in the demo account directory. You can find my personal menu, and on my personal menu is my merge that you can play with it in a virtual machine with nothing too important. Anyway, so how about that?